the cross product, it's another way, like we do dot product, that when you multiply the dot products, you get a scalar quantity, meaning a number. When you do the dot product, the cross product, you get a vector. So, and a lot of times this is used in physics. So if you have two vectors that are perpendicular to each other in a plane, when you do the dot product, it gives out another vector that is perpendicular to those two vectors. So, the cross product. So if you have, like, where's my rulers and my four x grids? So if these are two vectors somewhere in the plane, if you do the cross product between these two vectors, what you get out is a vector that comes out perpendicular, and it gives you another vector. And that's basically what it does. And it has applications in physics and all kinds of other applications that I'm not totally aware of. Yes, sir?
Why wouldn't it just give a vector like 45
Right.
Why wouldn't it just do it?
I don't know, that's the way it works. Okay, it just gives you a vector that's perpendicular to that. And so, but a lot of times that vector is useful. And this formula right here, V cross W, you could use that formula if you want, okay? So if you have two vectors, B1 means let me just show you that. So if I have one vector that is in the I direction, plus B in the J direction, plus C in the K direction. And then I have another vector W, okay, which is A in the I direction, plus B in the J direction, plus C in the K direction. And they call this A1, B1, C1. And am I in the way, sir? And they call this A2, B2, C2. Then to find the cross product, the thing that goes in front, the quantity that goes in front of the I would be B1 times C2 minus B2 times C1 minus, and then you just kind of plug into this formula. But it's a lot easier to do the, you could use this formula, but it's a lot easier using determinants, okay? And determinant, should that be determinant? I believe, A-N-T, okay? So anyway, if you have a little determinant like that, does anyone know how to do that? The value of this, all you do is you multiply it on the diagonal, and then you subtract. So this one gives you 4 minus 3. So it's 2 times 2 minus 1 times 3. And so the value of that is equal to 1. And determinants are a useful way to multiply lots of quantities that are in a matrix together, okay? So that's the value of a determinant like that. Now with this determinant, a 3 by 3, the way you do that, this is equal to A times the determinant, and what you do is you cross out the column that's A is in and the row that is A is in, and then you look at this quantity right there. So it's equal to A times the determinant 3, 5, that's a 3. 3, 5, 2, 3. Then it goes plus minus B times, okay? And you cross out this column and this row, the top row, and you get the determinant 2, 3, 1, 5. 2, 3, 1, 5. You guys see where that came from? Okay? It's what's left over when you cross out B's column and B's row, plus C times.
Why is it a minus B? Is it just?
Yeah, just the way the pattern works, it goes plus, minus, plus. Good?
Isn't it 2, 5, 1?
Oh, I'm sorry. Yeah. Thanks, Will. 2, 5, 1, 3. Why did I write that? I don't know. So that's 2, 5, 1, 3 there, right? 2, 5, 1, 3. And then you cross out C's column and C's row, and you get what's left over there, which is 2, 3, 1, 2. And then you do the determinant just like I did over here. So this is equal to 3 times 3 minus 2 times 5, which is 9 minus 10, which is negative 1a. Okay, minus 6 minus 5, right? 6, 2 times 3 minus 1 times 5, which gives you 1, right? So it's just minus b, and plus c times 2 times 2 minus 1 times 3, which is also 1, and that becomes plus c. So the value of this determinant is negative a minus b plus c.
Why did it become
Because why is this negative?
A?
Because it's 9 minus 10, right? 3 times 3 minus 2 times 5. Yes, ma'am?
So is that answer that you just got, is that the same answer that you'd get if you did the equation above it?
Yes. Yeah. Except this involves vectors, and instead of calling this I, J, K, they call this A, B, C. Okay? So to find a cross product, so the way you set it up when you're doing vectors, okay, is you put the IJK, you put the IJK in the top, okay? So if I want to do V cross W up here, the way I do that is I put IJK at the very top, IJK, and then I put the coefficients of my first vector here in the second row, 2, 3, 5. And then I put my coefficients of my second vector down here, 1, 2, 3. Okay? And just like I did before, you get this is equal to, I cross out this and this, and I get, are these the same numbers as we did before? Yes, they are. So I get 3 times 3 minus 2 times 5, so I get negative I. Do you guys understand what I did? I crossed out, let me get that in a different color. So when I'm doing that, I cross out this, and I cross out this, right? So I get negative I from going 9 minus 10, all right? Then I go to my next column, row, and that it goes plus, minus, plus. So the next one's going to be minus 2 times 3 minus 1 times 2 times 3 minus 1 times 5. So that's just minus 1j, right? When I cross out this, right? Cross out this and cross out this, and then I cross out this, and I get plus something k, and it's going to be 4 minus 3k, so that's just plus k. So this would be the vector that is perpendicular to these two vectors in space. Yes, sir?
So it always starts out with plus, minus, plus.
Yeah, it always goes plus, minus, plus.
Unless something's negative.
Unless something's, yeah, if this number came out to be negative, right? If this cross this comes out to be negative, then that would be positive, right? And W cross V, it works the same way, except you got to be careful because cross products are not commutative. It turns out that if I did W cross V, it would end up as plus I plus J minus K. So in this property down below here, if I could get to it, V cross W is equal to negative W cross V. So if I take the opposite of this, if I go in the opposite order, I end up with the negative of this vector. And V cross V, let's try that. V cross V. So I would get, I put I, J, K, and 2, 3, 5, right? 2, 3, 5, 2, 3, 5. And I would get 3 times 5 minus 3 times 5, which is 0. So I get 0I. What's that? Yeah, the whole thing equals 0. And then you're going 2 times 5 times 2 times 5, which would be minus, right? Minus 0j plus 0k, or just, which is just the 0 vector. Okay, so if you cross a vector by itself, you get no solution, which means that they're the same vector, or they could be parallel. If you end up getting 0, then they could be parallel.
Doesn't it mean there's an infinite?
Does it mean what?
There's an infinite number of vectors.
There's an infinite, oh, very good. There'd be an infinite number of vectors perpendicular to there because, right, if you think about it in space, you know, if this is one vector, how many vectors are perpendicular? Well, if I drew like kind of in a plane, right, if I spun around, all those vectors could be at 90-degree angles to that one vector, right? Good point, Antoine. All right, so that's where, so this property says that if you cross a vector with itself, you get 0. If you cross a vector with, you switch the order, it becomes negative. You can multiply by a scalar quantity, meaning you can multiply through by a number. So it would be equal, and so for instance, if you want to multiply the whole thing by 2, you would multiply one of the vectors by 2 and then do the cross product. Okay? And this says that it is the distributive property does work with vectors. So U cross V plus W is equal to U cross V plus U cross W. And then there's some of these properties. And there's pretty detailed developments of all these little rules and properties. So if you're interested in where they're derived from, you can look at that. But the vector U cross V is orthogonal to both U and V, which I just said. And this thing, U cross V, is equal to the magnitude of U times the magnitude of V times the sine of theta, and that's another way that you could find the angle between two vectors, okay, using this. But it's more complicated than using the dot product. We already have a formula for the dot product, but you could use this to find the angle between two vectors. And then U cross V is the area of a parallelogram having U and V as adjacent sides. So for example, if somewhere in space, let's use this, if somewhere in space you have two vectors hanging out, okay, like this and this, and I were to make a parallelogram and say this is vector U and this is vector V, U and V. If I took the cross product of those, I would get the area of a parallelogram that looks kind of like this. And I looked up in the book why that's true, and it has to do with this formula. And what you're really doing is you're finding, when you do that, you're finding the height. You're finding the height of this parallelogram, okay? Because, and then you're multiplying that height times the, anyway, but times the base, and you would get the area of that parallelogram. But this formula, if you take the magnitude of U cross V, you would have the vector, the area of a parallelogram with those two sides as vectors. And U cross V equals 0 if and only if U and V are parallel. Okay? or the same vector. All right, so moving on. Find a vector orthogonal to these two, and all you have to do is do the cross product, okay? And so I guess it doesn't really matter which order you go in, because both, if the two vectors that you'd be getting, they both be perpendicular. One would be going the opposite direction, you know, if you did U cross V versus V cross U. But I would just go U cross V, okay? And that's equal to the determinant I, J, K, 3, negative 2, 1, negative 1, 3, negative 1, and then you just do it out. So what do you get for what goes in front of the I? Negative 1. Everyone see where we got negative 1? Negative 2 times negative 1 is positive 2, minus 3. So you get negative I. And then you look at the J, and you cross out this and this. So 3 times, so, and it's minus, right? 3 times negative 1 is negative 3. So let's kind of do that together. So that's minus 3 minus negative 1 times 1, which makes plus 1, right? J. So sometimes you might see where I got that? 3 times negative 1 makes negative 3. Minus negative 1 times 1 makes positive 1. And there's a minus sign front. So people make mistakes a lot with the sign of things, because they forget that this is a minus, or they forget that they subtract. And then the K, plus how many K's? It would be 6 minus 2, right? So that would be plus 4K. No? Not, oh, I knew that. I knew that. 3 times 3 is 9, isn't it? Okay. 3 times 3 is 9 minus 2. So that'd be 7, right? Hurrah?
No.
I did that right.
It's negative 1 plus 2.
9
Oh, yeah.
minus 2, because it's 3 times 3 minus negative 1 times negative 2. So you have to be really careful, because they're easy to make some mistakes doing this. Okay? So you get negative 1. This is minus 2, but it's minus, so it makes plus 2K. And,
J.
and is that right? 2J, sorry. 2J. 2J. And then plus 7K. So that would be the vector that is perpendicular to those two vectors. Find the area of a parallelogram. So this one down here can be a little bit tricky in that, look, and then we're done. That's easy. So this one here can be kind of tricky, because I'm going to just draw an X, Y, Z axis. X, I should have gone the other way. Okay, X, Y, Z axis. So, you know that 0, 0 is here, right? But in 3 dimensions, they will tell you, I think, on a test, but not on your homework, where these vectors end up. So if I have the vector P1 to P2, so if I go out 3, back 2, up 1, so let's say this is vector, we'll call this P1, this vector is P1, P2. See that? And then this vector, P3, it originates at, if I want to do a vector originating at 0, it would be back 1, over 3, down 1. Okay? So that vector would go something like down here. So here's the vector P1, P3. And then you have another vector P1, P4. P1 to P4 would be over, out 2, over 1, and down 0. Okay? So, where's that little vector? Right over here. But, where's my arrow on that vector? Well, I guess it doesn't draw arrows if it's rich. So this is P1, P4. But you don't know which two of these, one of these is going to be the diagonal of a parallelogram, and because these points connect, okay? But you don't know if it goes like this side, then this side, then this side, or if it goes this side, then this side, and back to here. So in 3 dimensions, it's hard to tell. So what you have to do is you have to add up 2 vectors to make sure they add up to a third vector. So P1, P2 is the vector. Well, do you see that if I add up this one? Do you see that P2 plus P3 adds up to this one? P2 plus P3 equals P4. Do you see that? Because if I add 3 plus -1, I get 2. And if I add -2 plus 3, I get 1. And if I add 1 plus -1, I get 0. That must mean that P2 and P3 are adjacent sides, and P4 is a diagonal, okay? So that the vector going from here to here and here to here are adjacent sides to a parallelogram, and this vector here, even though it doesn't look like, is a diagonal of that parallelogram. So this parallelogram might look something like this, okay? So you have to kind of figure out which vectors need to be you need to cross to get the area. So in this case, add these two together, P2 plus P3 gives you this. So you know that this must, if this plus this equals this, then this must be the diagonal of that parallelogram. Okay, so now I'm going to cross this one with this one. Okay, so I'm going to go P2 cross P3. And so that I'm going to go I, J, K. And I put P2 is 3, -2, 1. And P3 is -1, whoops, -1, 3, and, sorry, -1, 3, and -1. And then I just do the cross product. And in the I direction, I get +2, -3, right? So I get -1 in the I direction. And I'm going to put a minus sign in front of my J. And my J is going to be -3 minus -1. So it's -3 plus 1. So that makes -2, but since this is minus, it turns into plus 2J. Okay, see that? Okay. Plus this times this, right? So 9 minus -2 would be 7 again, right? Is that right? 9 minus 2. 9 minus 2, because it's negative, yeah. So that gives you 7K. Now to find the area of this parallelogram, what I do is I take the magnitude of that. So the magnitude of P2 cross P3, you just find by taking the square root of these squares. Okay? Yes?
Why would it be 9 minus 2?
9 minus 1 times -2 makes +2, but you always subtract. It's this minus whatever that product. Okay? And so this is -1 squared plus 2 squared plus 7 squared. And that's equal to square root of 53. And that's 49 plus 4. No, 54. Rob made a mistake. Is that the first mistake you've ever made? No? Okay, so that's square root of 54. And that's equal to square root of 54. And that's the area of this parallelogram right there. As far as the volume of a parallelepiped, what that means is if I had a vector, parallelepiped is like a three-dimensional parallelogram, like something like, if I were to draw, I don't know if I could even draw, something like going up this way and this way. You know what I mean? Kind of like that. And if this were that third vector coming out this way, I could find the volume by multiplying B dot U cross W. But we don't have to do that. We don't have a homework problem. And that's it. Okay? So this is kind of the hardest thing, is figuring out which two sides to multiply. But it's really not that bad. Yes? And